Good afternoon, students. In the previous class, we have studied regarding parallel and series combination and so many mixed numericals related to it. But today, we have to study regarding heating effect of current. Another term is electrical power and the relations between all the terms of heating effect and electrical power. And finally, last will be your numerical. First of all, that is heating effect of current. Heating effect of current. If H be the amount of heat produced, this depends on, means it is directly proportional to the square of the current flowing through it. And second is, the amount of heat is directly proportional to the resistance. And number third is directly proportional to time taken to flow the heat. You have made several experiments in your student life, taking a wire in a plug, and next arrangement in case of heater to heat the water. You have already made. The amount of heat depends on these three factors. The square of the current depends on resistance and time taken to flow the heat. Combining all these terms, we will get H proportional to I square RT. Always use a proportionality constant. So this formula we can write in this way. This constant is 1 I square RT. This is the first equation. From Ohm's law we have studied V is equal to IR. So the value of I can be written as V by R. So the equation first becomes, this is your I square, putting the value of I as V by R, V by R whole square into R into T, and we can write it V square by R square into R into T. This R and this R cancel, so we can also write in this way V square by R into T. This is your equation number second. Another result, this is also the value of H R. Now we will put the value of R here from first. From equation first, we can write H is equal to I square into this R. R can be written as V by I. Since from Ohm's law, V is equal to IR, so R is equal to V by I. I into T. This I and I square will cancel, and finally we can write this into this into this. So we can write it as V I T. This is the third equation. These are the three equations for the amount of heat. This is equal to VIT. Not Vellore Institute of Technology. Here V indicates what? PD. I, that is current, and T is the time taken. And finally we can write by these three equations, H can be written as I square RT from first. This must be written as second equation, V square by R into T, and third equation, that is VIT. VIT. It can be locked. Always remember all the numericals related to it. You have to apply which equation. It depends on the question. Which type of question is being asked. If the terms, it depends on the terms given in the question. Term is electric power. Just I have written the rate at which electric energy is dissipated or consumed both in an electric circuit. That is your electric power. It is denoted by P. Power. You all are familiar about power in class 8 and 9. Power means rate of doing work, that is called power. So rate of doing work means work done by time. Heat is the form of energy. So we can write this is equal to H by T. Just I have seen three formula regarding H. First formula was I square RT divided by T. So it can be written as I square. This is the very first formula for the power. Again, another formula, just I square RT, that was your V square by R into T. V square by R into T. This is the value of amount of heat. This divided by time. So this T will cancel. It can be written as V square by R. So P is equal to V square by R. That is your second formula. Third one, just I have shown to all of you. H was VIT. Remember it. So power, that will be equal to VIT. This was the value of H by T. Already written the rate at which electrical energy is dissipated. So this by T. So it can be also written as V into I. This is your third equation. From first, second and third, the final result also we can write from equation 1, 2 and 3. P can be written as first formula, that is I square by I square into R. Second is your V square by R, and third one is V into I. This one we will use equation 1, 2 and 3 according to the need of the question. Which item is given and which is to be obtained. It depends on the nature of the question. I will derive so many problems. Okay, that was electrical power. SI unit of heat. SI unit of heat. Heat is the form of energy. What is the SI unit of energy? You are familiar about SI unit of energy. That was Joule. So we can write SI unit. SI unit of heat, that is equal to Joule. It can be written in so many forms. Calorie is also a unit. Calorie and Joule, there is a relation. 1 calorie is equal to how much Joule? 4.2 Joule. Actually it is 4.18. We can write 4.2 Joule. And this is your power. The SI unit of power is watt. SI unit of power. Power. It is used for heat. It can be written in so many forms. Power. It is watt. There is a term. Commercial unit. Commercial unit. Can I write commercial unit? Actually it is kilowatt hour. We can write 1 kilowatt hour. There is a relation between kilowatt hour and joule. 1 kilowatt hour, it can be written as 1 into kilowatt, can be written as 1000 watt into hour. 1 hour is equal to how much? 60 into 60 seconds. 1 hour means 60 minutes, and 1 minute is of 60 seconds. So it can be written as 36 into 10 to the power 5 is equal to, it can be written as 3.6 into 10 to the power 6 joule. So 1 kilowatt, that is commercial unit. It can be written as in terms of joule, 3.6 into 10 to the power 6 joules. There are so many relations. Just we have seen, it is especially used during consumption of electricity. In household circuit, we have seen electrical bill is given in money, but unit is always in kilowatt hour. Electrical bill, we always use this one. So we can calculate so many examples. Look at this numerical problem. First, that is, torch bulb is rated 2.5 volt and 750 milliampere. Calculate power, resistance, and third is energy consumed if the bulb is lighted for 4 hours. We have to calculate 3 items. First, what is given? Are you watching? First term, torch bulb is rated 2.5 volt. We will write V is equal to how much? 2.5 volt. Okay. Milliampere. This is the value of current. I is equal to 750 milliampere. You have to convert milliampere into ampere. So 750 by 1000 or 10 to the power minus 3, it is ampere. We can write. You can also write 75 into 10 to the power minus 2. That does not make. First item is power. Power. There were 3 formulas. Remember, among that 3, remember last formula, most probably it was V into I. Power means P is equal to V into I. That was the third one. Since the value of V and I, that is already given. V is equal to 2.5 and the value of I is 750 into 10 to the power minus 3. If you will multiply this into this, 750 into 2.5, 750 to the 1500, half of 750, that is 375. So we can write 18 5 into 10 to the power minus 3. There should be no confusion. This by 10, 0 cancel. 75 into 25, this product must be this. So this is the value of power. What is its unit? Watt. If you desire to write in terms of kilowatt, how can you convert it? Divided it by 1000. Result will be 1875 into 10 to the power minus 6 in terms of kilowatt. Second item, that is resistance. Remember the formula resistance. From Ohm's law, very clear, V is equal to, what was Ohm's law? I into what? R can be written as V by I. Okay? The value of V is given. This is 2.5 by, this is your I. This one, 750 into 10 to the power minus 3. You can solve it. It might be 25 by 7500, and this 10 to the power minus 3, it will be this in terms of this one, this 0 and 10 to the power 2 cancel, only 10 remains. 25 by 75, 1 by 3 into 10. So it will be 3.33 resistance, unit of resistance, ohm. Clear? Third item, that is, you have to calculate energy consumed if the bulb is lighted for 4 hours. Formula for energy, just we have seen, P is equal to H by T or E by T? H by T or E by T. So energy consumed, H is equal to, it is the form of energy, P into T. If you will put the value of P and T, P is already we have calculated here. P is equal to how much? 1875 into 10 to the power minus 3. Multiplied by time. What was the time given? Energy consumed for 4 hours. 4 hours. It can be converted into second. 1 hour, 60 minutes. 4 hours will be converted into second. Can you multiply it easily? 4 into 60 into 60. Then you will find your answer in this way. I am writing, you can easily solve it. Just for your help, 10 to the power minus 3. 4 hours means 4 into 1 hour, that is in terms of minute 60 minutes and 1 minute 60 seconds. You will solve it and finally you will get the value of energy consumed. Its unit will be joule. Finally you have to write joule after solving it. Okay? Children, I am recalling all the previous formulae. First is your V is equal to IR. Just we have studied in Ohm's law. V, it is potential difference. I, current, and R is resistance. Second is R is equal to rho into L by A. This is the resistance of the wire. This is resistivity of the material, or we can say a specific resistance. L is the length of the wire and A is cross sectional area. When resistors were joined in series, we have studied in series combination, the equivalent resistance is equal to sum of the individual resistance. In case of 2, that R must be equal to R1 plus R2. In case of 3, this, so on you will add it. Fourth is parallel combination, 1 by Rp. This is total resistance of the combination when they are joined in parallel. That is 1 by R1 plus 1 by R2 plus 1 by R3. And fifth formula, just we have studied heating effect of current. H is equal to I square RT, where H is the amount of heat produced, I is the current, R is the resistance, and T is the time taken to flow the heat. And this formula has been derived in 3 ways. H is equal to V square by R into T, H is equal to V IT. From these relations we can solve any numerical according to the nature of the question. And last is your electrical power. This electrical power can be written in this form. First is, this is equal to I square R, second V square by R, and third one is V into I. So children, try to remember all the formula that will be used to solve the numerical problem in the next class. Okay, I conclude my class. Take care and be